Hey Opties! Today we're going to be looking at some dilations problems on Khan Academy. So let's go ahead and get started. Okay, so the first dilations practice we're going to be looking at is dilations scale factor. So a scale factor can be either between 0 and 1, making a reduction dilation, or it can be greater than 1, making an enlargement dilation. So let's just read and see what we're supposed to be doing here. Pentagon A prime, B prime, C prime, D prime, E prime is the image of pentagon A, B, C, D, E under a dilation with a scale factor of 1/2. Okay, so let's dissect that into what we know by looking at that. So this is the image. It's kind of like, I like to call it maybe the result, in case you struggle with the words image and pre-image. And this is the pre-image. So that's the thing we start with. And I'm writing pre-image as well because the sentence doesn't say that. And this is like the original. And that's what we have graphed here. So you take what we have graphed and you dilate it by 1/2 or 0.5 or 5/10, however you want to say it. That means you're getting half as big on each side length. So the question we have is, what's the length of segment C prime, D prime? So let's find the length of CD, and that looks like it's 1, 2, 3, 4 units long. So CD is 4 units. So from CD to C prime, D prime, we have to go half as big. So we can say that 1/2 times CD equals C prime, D prime. So what is CD? It's 4 units, and half of that is 2. So 2 is our answer. And you might have done that in your head, but I also wanted to show you how to write that. So it's going to be 2 units because we're getting half as big, and the original side length we were looking at was 4 units. So let's check. And we are good. Let's look at this next one because it gives us a picture of our image. So the result picture or figure, and we want to do something to find the length of one of the segments or the sides on our pre-image. So we're kind of going backwards here. So let's read. Pentagon A prime, B prime, C prime, D prime, E prime is the image of pentagon A, B, C, D, E under a dilation with a scale factor of 3/2. So 3/2 is important. And we're looking to find AE. So some scale factor times AE equals A prime, E prime. And we know what that scale factor is. It's 3/2. We don't know what AE is. And we do know what A prime, E prime is. If we just look at our graph, we can count 1, 2, 3, 4, 5, 6. So it's 6 units long. So we can solve this like a little equation, and we can either divide both sides by 3/2, or what I would prefer is we can look at it like, instead of dividing by that fraction, we can multiply by the reciprocal. So multiply by 2/3 instead of dividing by 3/2. Just makes it a little easier. Personally, I think it's better. Those all simplify to 1, so we find that AE is equal to 6/1 times 2/3, which is 12/3, which is 4. Before we submit our answer, let's kind of go back to our image and make sense of this. 3/2 is bigger than 1. So this is going to be an enlargement dilation. So from the original, it should be smaller than the result picture or the image. So from pre-image to image, we should be getting bigger. So if this side length is 6, this one should be smaller. And if you want to test to see if that's correct, just kind of work your way backwards and say, well, is 4 times 3/2, is that equal to 6? And this is a really great way to check. 4 times 3 is 12. 12 divided by 2 is indeed 6. So that's a good way to check. And we're just looking back at that picture to make sure we understand. Now let's check to see if we've gotten it correct. And we're good. Next, let's look at dilation's center. Remember in our notes, we talked about how when we line up the corresponding vertices of dilated figures, like so those line up, and those line up. When we extend them, they all should intersect at a special point called the center, which is that starting point. That's where we're dilating from. So to figure out which one of these is the center, A, B, C, or D, we could extend these. It's good to extend them in both directions, just because you may not know where they're going to intersect first. And it looking like it's going to be A, since we already have 2 intersections there, and we see we do have that 3rd intersection there. So our center is A, and that's really all it is to do this assignment. Let's check, and we are good. Lastly, we have dilate triangles. So we're actually going to be making the image of our given pre-image here. So let's kind of move this around to see what we have here. Draw the image of triangle ABC, which is the blue triangle here graphed for us, under a dilation whose center is P. So this is our center, point P, and a scale factor of 1/2. Okay, so our scale factor is between 0 and 1, so this is going to be a reduction. So let's keep that in mind. And a really good thing to think about when you're almost ready to submit is make sure that they have the same shape. So let's make sure we check that they have the same shape, because it could be you are really close and you're just maybe one little point off. And if you can tell that they're not the same shape, it'll help you identify that. So I myself might want to just go ahead and put my triangle on top of the other one. There's different ways to do it, but I think this helps. So the way to actually do this is connect your center to a vertex to dilate that point. So it's like our dilate points, but we do it 3 times for these 3 vertices. So let's find this distance, and then we're going to take half of it starting at the center. So it's really not going to be very feasible to find this diagonal distance, but we can do the rise and run. So let's do the run. 1, 2, 3, 4, 5, 6, 7, 8. And then let's figure out this rise. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 as well. So half of 8 is 4. So we can go right 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. And we have that prime point. So I guess it's going to be, yeah, A prime. And a good check is to make sure that it's on the same line segment that connects that center of dilation to that vertex you're wanting to dilate. Let's look at C to find C prime. So let's find this distance. It is a straight distance. It's not diagonal. So we can simply just count our squares, and let's do that, or our units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10, and half of 10 is 5. So let's start at the center. See, it's giving me problems. Here we go. 1, 2, 3, 4, 5. Okay. And now let's find B prime. One thing you could do is figure out the proportion from C to B and half those distances instead of halving the center to this point. I'm going to do that since we've already done it 2 ways, from the center to the points we want to dilate, because you want to find the same shape, right? So It's got to be over here somewhere, and that looks like it might be right, but let's definitely double check. Maybe even that one. So the height between C and B is 2, so I should have gone down 1, which is right there. So it's going to be somewhere along this line, if you can visualize that. And now let's take half the distance, the x distance, or the left and right distance from C to B. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so half of 12 is 6. So 1, 2, 3, 4, 5, 6. And that should be our triangle. And if we check, they do look like they are the same shape. You could also definitely check, and I definitely would do this if you're unsure, check these side lengths. So we have 8.2, and if we divide it by 2, we should get 4.1 if we've done it correctly. And we do, so that one's good. 12.2 divided by 2. And the reason I'm dividing by 2 is it's the same thing as multiplying by 1/2. I'm just applying my scale factor here. That should equal 6.1 because this side corresponds to this side, and it does. And lastly, let's check 5.7 divided by 2. Does that equal 2.8? And it does. So we're good to go. Let's check. Awesome. All right, Opties. I'm hoping that really helps you on your Khan Academy assignments, helps you understand more about dilations in lots of different forms. See you next time.